Okay, class, picking up where we left off at, we was multiplying everything by 1/2, and after we put this in our calculator, this would give us x is approximately 3.477. And that is our final answer for that problem. Now we go here to D. Now we have 6 to the 2x times 6 to the x plus 1 is equal to 125. Remember, when we have a base times a base, we add the exponents. So it'll be 6 to the 2x plus 1 is equal to 125. So it'd be 6 to the 3x plus 1 is equal to 125. So we will have log 6, 3 to the 3x plus 1 is equal to log of 125. Now, we could bring this 3x plus 1 out front. We would have log of 6 is equal to log of 125. We divide each side by log of 6. And we'll be left with 3x plus 1 is equal to log 125 over log of 6. Now we know we're going to subtract 1 on both sides. So we have 3x is equal to log 125 over log 6 minus 1. And then we will multiply everything by the reciprocal of 3, which is 1/3, to get x by itself. And we will have x is approximately 0.565. And we're done with this problem. Now, we scroll down here to the next page. It says when you cannot solve an equation by hand, if the variable appears both inside a logarithm and outside a logarithm, if the variable appears both in an equation out of an exponent, these are the two situations where you cannot solve it by hand. But it is possible to solve any algebra equation using a graphing calculator. Simply graph each side of the equation as a separate function and find the intersection point. Example 6, find the solutions of the following equation. Show a label sketch of the graph for work. Give 3 decimal places. So first of all, we will put this in our graphing calculator. This will be your y1 and this will be your y2. So you will put this in your graphing calculator. So we'll graph both of these separately and then find the intersection. So put this in your calculator. This will be your y. So you know you'll have y1 equals, and you will put this there, the 2 plus 3x. And then also you have y2 equals, you'll put log x plus 4 in your calculator. Now, when you put these values in, graph them, and find the intersections, you will end up with a long number, a long decimal, but I want you to round this to 3 decimal places. But first, let's write that out. This is what you will be given. Now I'm running out of space, so it'll be 9, 6, and then 507. So this is the 2 points you will have. So here we will have x is approximately a negative 0.485. And so we know y will be approximately 0.546. Wait a minute, let me write that here. Y would be approximately 0.546. Okay, so now it says find the solution of the following equation. Okay, now if you notice here, we do not have a y value, so we don't need to include this here. So this right here would be our final answer. X is approximately a negative 0.485. Now what we're going to do here is this here, because like I said, as far as graphing is concerned, it'll be easier for me to put a sketch here. So here's a quick look at what the sketch should look like. These two order pairs here intersecting, and this is what it should look like in your calculator. Okay, So now we scroll down here to this last problem. Again, we will graph this like we just did the previous problem. This right here will be our x1, our y1, and this here would be our y2. Now, we put this in our calculators and graph it, and we will get the order pair 1.212 and also 3.788. Now, that's with us rounding. So x is approximately 1.212 because as you see here, we don't have a y value. So when we put this in our calculator, the sketch we would end up with is, we will end up with this sketch here showing the intersection at these approximate points. So you just put this in your calculator, graph it, find the intersection point, and draw this representation here, and we're done.